Good morning, students. Welcome to my YouTube channel. This is Agilawan channel, and we have to discuss the colors in light. By yours truly, this is Sir Dante, and we have the most essential learning competency and objectives. In this module, you will learn to explain the hierarchy of colors in relation to energy of visible light. Specifically, you will learn to infer that white light is made up of many different colors. Number two, describe the wavelength and frequency of different colors of light. Number three, explain how wavelength and frequency are related to energy of visible light. And we have a table here. So this is the table of color spectrum. Okay, on the first table we have three columns. The first column we have the column of color spectrum. We have red, orange, yellow, green, blue, and violet. On the second column, the frequency in uh, in THz. Ano ba yung THz? That is terahertz. Okay? When you say terahertz, uh, equal to 1000 gigahertz. Okay? When you say frequency, this is the number of wave. Okay? Of these colors. Okay, red 422 frequency, orange 484 frequency, yellow 570 frequency, green 566 frequency, blue 638 frequency, violet 744 frequency. And on the third column, we have the wavelength. Ang unit po niya ay in nanometers. Right, nanometer. So, the red 700, orange 620, yellow 580, green 530, blue 470, violet 400. Right. So these are the wavelength of these colors. So exploration spectrum table. The following data corresponds to the frequency, wavelength, and energy of the colors of light. Okay? Colors of light from red to violet, and we have also the frequency and we have the wavelength. May nadagdag po dito, we have the energy. Ang yun po niya is EV. Ano yung sabihin ng EV is electron volt. Ayan, yan po ang electron volt or energy ng bawat color. Yung red po, meron siyang 1.77 electron volt. Yung orange, meron po siyang 2.00. And yellow, 2.14. Green, 2.34. Blue, 2.64. Violet, 2.95. Okay. Ano ba ibig sabihin ng color spectrum? Ang color spectrum po, these are the colors from the sunlight passing to the prism. Yan. Yan po ang ibig sabihin ng color spectrum. Okay? So, in 1666, Isaac Newton did his first scientific experiment on the colors, producing when a narrow beam of sunlight passed through a prism. He called the order arrangement of colors from violet to red as a spectrum. Yan po. Yung from red to violet or violet to red, yun po yung mga spectrum colors. Sunlight is often referred to as white light because it is the combination of all visible colors. When it passes through a prism, it separates into the different colors in this order: red, orange, yellow, green, blue, indigo, and violet, coining the acronym ROIC-BIV. So, ROIC-BIV. Okay, what is indigo? Okay, sino ba sa inyo nakakalam ano kulay ba ng indigo? Indigo is a dark blue. Okay? Yan po ang indigo. So, this process is called dispersion. Yan. Kapag nagkaroon na po ng iba't ibang colors, galing dun po sa white light, nag-pass through, na dumaan po sa prism, nagkaroon po siya ng red, orange, yellow, green, blue, indigo, and violet. So, nagkaroon po ng process, ang tawag po dispersion. Dispersion is a special kind of refraction that happens when white light splits into the different colors when it passes through the glass prism. So this phenomenon has something to do with wavelength, frequency, and refractive indices of the colors of light. So this is the picture of the prism. This triangle is an example of prism. The white light from the sun passes through the prism and nagkaroon po siya ng dispersion of light. So, mayroon pong red colors or red light, orange light, yellow light, green light, blue, and violet light. So, yan po nangyayari. So, light is transmitted on several frequencies and wavelengths. And what we know as colors are actually visible wavelengths of light traveling a different speed through different media being reflected back to our eyes. So it is dispersed based on wavelengths, frequency, and the material index of refraction. Thus, they appear as a spectrum of colors to our naked eyes. Red, since it has the longest wavelength, appears on top of the spectrum. Tandaan nyo the red is the longest wavelength appear on the top of the spectrum. Siya po yung nasa taas. And followed by, shortly by orange. Ito po yun, may orange siya. May yellow. Sunod po sa kanya yung green. Sunod sa kanya yung blue, indigo, or dark blue, and violet. Tignan nyo may light blue, may dark blue. Ang dark blue po ang tawag dyan, indigo. Okay? But these colors do not appear as perfectly distinct but blend at the edges. You may have noticed the blue appears at the bottom. This is because violet is not very visible due to the cones in our eyes that are not sensitive to it. So yung po ang arrangement ng colors ng spectrum, color spectrum. Red, orange, yellow, green, light blue, dark blue, and violet. Okay? Don't forget the arrangement. And remember your lesson in grade 7 about the relationship between frequency, wavelength, and energy. So frequency and energy increases as the wavelength decreases. Tingnan nyo tandaan nyo, kapag tumataas daw yung frequency at energy ng light, yung wavelength niya nababawasan. So from the colors of the rainbow, we can say that red has the longest wavelength and the lowest frequency and energy. Yung pula po sa rainbow, yan po yung pinakamahaba na wavelength, pero siya po yung pinakamababa ang frequency and energy. Tingnan nyo dito. See, for instance, this is the color of the rainbow, yung red. Tingnan nyo, 1, 2, 3, 4. Mayroon lang siyang 4 frequencies. Diba? Pero, maski na mababa yung frequencies, siya po yung pinakamahaba na wavelength. Okay? Right. The higher the frequency, the faster the oscillations, and thus the higher the energy. Yan. Kapag mas mataas daw yung frequency, mas mataas daw yung kanyang oscillation. Okay? What is oscillations? This, when we say oscillations, this is the movement back and forth at a regular speed. Okay, yan po ibig sabihin oscillations. So, therefore, the higher or the highest frequency, which the highest energy is violet. Tingnan nyo. Tingnan nyo dito, sa violet. Bilangin natin yung frequency. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 frequencies compared to the red. 1, 2, 3, 4. Nang ano ba? Mas maraming frequency ng violet. Kapag mataas ang frequency ng isang color, mataas na yung kanyang energy. Diba? Pero yung kanyang wavelength ay mababa. Okay? So this is the wavelength of different colors. Diba? From red, ang violet, habang pababa po siya, tumataas yung frequency, but bumababa naman yung wavelength. Di ba? So, yun po nangyayari. So, below are some of the applications of dispersion. So, we have the dispersion in soap bubbles. Tingnan nyo, sa sabon. May mga different colors. Dito naman, sa nature's dispersion, the rainbow. Dito, sa mga CDs and DVDs, dispersion in CDs or DVDs. So, bakit nagkaroon ng ganito, mga colors? Because of sunlight. Without sunlight, without light, hindi po siya magpuproduce ng colors. Diba? Kasi walang mangyayaring dispersion. Right? So, in the electromagnetic spectrum, we can find visible lights or light. The rays just beyond the red end of the spectrum are called infrared. On the other end of the spectrum are the blue light rays, which are sometimes called the blue violet or violet light. Hence, the term ultraviolet radiation. Diba? So blue light is visible light ranging from 380 to 500 nanometer, and approximately one-third of visible light is considered high energy visible or HEV or blue light. Primary source of blue light is sunlight, but can also be found in fluorescent lights, LED lights, flat screen LED, TV, computer monitors, tablets, and smartphones. So ano ba yung benefits at disadvantage ng blue light sa atin? In summary dito, when say blue light, can be the source are the sunlight or yung mga gadgets po natin, yung mga electronics po natin na may mga monitor. Okay? So, what are the benefits of blue light? Number one, exposure to blue light helps memory and cognitive functions. It also helps maintain a healthful circadian rhythm, our body's natural wakefulness and sleep cycle. Number two, photodynamic therapy, in a method that combines blue light with drugs, activating blue light's wavelengths used to treat jaundice in newborns. Number three, light therapy is used to treat seasonal affective disorder or SAD, which is a type of depression that is related to changes in season. Yan. Yung may mga tao na depressed, ang blue light po, nagiging siyang light therapy. Alright? Dito naman sa number one, nakakatulong po sa ating memory at cognitive function. Sa number 2 naman, pwede po siyang gamitin sa drugs. Sa mga drugs para makatulong po sa ating mga sanggol, di ba? So sa number 4 naman, blue light is also possible affecting or effective in treating skin problems. Yan. Magaling po to na pang gamot sa ating mga skin problems. Kaya po ang advice nga sabi ng iba, ng mga doctors o yung mga matatanda, wake up in the morning as early as 5 o'clock to 6 o'clock. Hintayin nyo sumilip yung haring araw at kayo magpabilad. Bakit? Kasi dun po sa sunlight, meron po tinatawag na blue light at meron tinatawag na far infrared. Okay? Yung far infrared po nakatulong po sa pag-alis ng ating mga pain sa katawan natin kapag po tayo ay nainitan yung ng araw between 5 to 6. 5 to 7. So early studies show that a deficiency in blue light exposure could contribute to the recent increase in nearsightedness. Ano ibig sabihin nearsightedness? Kapag ikaw ay nagbasa at hindi mo mabasa ng malayo, nahulugan, ilalapit mo po yung babasahin mo, saka mo lang nabasa. Ang tawag sa'yo nearsightedness. O kaya naman, nanonood ka ng TV, malayong TV, hindi mo nababasa, pero nung lumapit ka, nabasa mo o nakita mo yung picture. Diba? So nakakatulong itong blue light para maiwasan natin yung nearsightedness. But, dito naman, mayroong disadvantages. So, blue light has its benefits but it also possesses danger to us. Number one, it contributes to digital eye strain. When you look at digital screens for a longer period of time, it is convenient to use blue light filter to avoid or minimize eye strain that could be led to eye problem. Okay? So, in other words, kapag matagal kang gumagamit ng mga gadgets, yan, magkaroon po tayo ng eye strain. Kaya, in-advise na lagyan ng filter yung mga screen ng laptop, yung desktop, di ba? Para maiwasan nating eye strain. Number two, it may increase the risk of macular degeneration which could lead to permanent vision loss. Yan. Yan pong ibig sabihin nun. Kaya, iwasan po natin yung masyadong ma-expose sa blue light. Pwede kayo mag-expose pero in a shorter period of time. Okay? Okay, what accounts for the color of the sky? Answer to this question depends on the following factors. We have three factors. Sunlight is made up of colors of light with different wavelength. Number two, the presence of particles in the air that scatter this different wavelength of light is a different amount. Number three, our eyes sensitive to this wavelengths. Yeah. Ito po yung three factors kung bakit may mga colors po sa light natin because of these factors. Unang-una, yung sunlight po natin may mga wavelength. Okay? Pangalawa po, yung particles po sa ating air naka-scatter doon. Okay? So, pag dinaman po siya ng wavelength ng sunlight natin, doon po nagdedepende yung kulay ng sky natin. So, our eye is sensitive to this wavelength. Kaya, kuminsan, pag tumingin tayo, ang ibang napapansin, ay ibang kulay ang nakikita, yung iba naman, kasi siguro yung ibang mata natin, yung ibang mga mata ng ibang tao, may mga problema na rin. No? Kaya po nagkaroon ng pagtingin sa ibang colors. Okay, sa sky. So, when sunlight reaches the atmosphere, it is scattered in all directions because of the presence of particles found in the air. Shorter wavelengths are more scattered. Tignan nyo yung pinaka-maximum wavelengths po ay mas marami na scattered. From our lesson on the concept of dispersion, it could have been violet that is more scattered in the sky since it has the shortest wavelength. So, why is the sky blue? Yan, tanong. Di ba? So, sabi dito, it could have been violet that is more scattered in the sky. Kasi yung violet po, siya po yung pinaka-mixing wavelength. Pero, mas marami siyang frequency. Diba? Pero ang tanong, bakit blue ang nakikita natin sa kalangitan? So, aside from the fact that our eyes are less sensitive to violet, we have color receptors in the retina of our eyes called cones. Mayroon po tayong cones sa mata natin. These cones are sensitive to red, green, and blue wavelength. Tandaan nyo yung cones po sa mata natin, yung cones po, nandun po yan sa retina natin. Yan po sensitive sa kulay na red, green, at blue wavelength. There are also monochromatic rods. These four receptors transmit signals to our brain, and our brain interprets it into a color. So the red cones respond to the small amount of scattered red wavelength, but less to orange and yellow wavelength. The yellow cones respond to yellow, green, and green-blue wavelength. So the blue cones respond to colors near the blue wavelength. On the other hand, the most scattered violet wavelengths stimulates the red cones slightly as well as the blue. So the overall effect is that the red and the green cones are stimulated almost equally and blue is stimulated strongly. So our eyes respond more strongly to blue, cyan, and green wavelength. What is cyan? When we say cyan, this is This is the greenish blue colors. Okay? So so our eyes respond more strongly to blue, cyan, and green wavelength that they do to violet to the sky appears blue. So talaga, ang nakita talaga natin because of this explanation, blue talaga. Okay? So, yan po talaga. Hindi yung sinasabi nila diyan. Kaya blue yung langit natin kasi majority ng surface ng Earth natin is ocean. Nagre-reflect daw yun sa sky. Hindi yun. Because of this explanation kaya po nagiging blue yung kulay ng mata natin. Blue yung sky pala, hindi yung mata. Okay. Vocabulary list. So blue. Blue light or blue light. Visible light ranging from 380 to 500 nanometer comprises approximately one-third of visible light. Considered high energy visible or HEV. Yan po yung blue light. And cones. Photoreceptors found in the center of retina of the eye which provides vision during the day. Yan, nasa mata po natin yan. Nasa retina, center ng ating retina. Dispersion is special kinds of refraction that happens when white light splits into the different colors when it passes through the glass prism. Yan. Yan po yung dispersion. Yung mga, di ba, nakita natin red to violet. Because of dispersion, nangyayari po dispersion kapag tumawag po sa prism or glass prism. Energy, ability to do work, is inversely proportional to wavelength. Yan. Frequency refers to the number of wave cycle that passes by the particular point per unit time. Yan, number of waves, Yan pong frequency. Nakita niyo kanina yung itinuro ko, di ba? Hierarchy, the arrangement of colors that is perceived by our eyes. Yan. Yung arrangement daw ng colors, di ba? From red to violet. Yan. Yung, in other words, ng hierarchy is the ranking. Yan. In general. Index of refraction, the measure of the bending of light when it passes from one medium into another, which is equal to the velocity of light of a given wavelength in empty space divided by its velocity in a substance. Okay, medium, a substance that makes possible the transfer of energy from one location to another. Prism, a triangular piece of transparent materials. We have the word reflection, is the bouncing back of light. Rods, this is the photoreceptors found in the boundary of the retina of the eye, provide vision in the dark. And we have the word spectrum, the band of different colors resulting from the dispersion of colors starting from red to violet. Vacuum, an empty space devoid of any matter. And the last one is wavelength, the distance of wave between adjacent points that are in equal phase. Right, that's it. Thank you so much for watching this video. Don't forget to subscribe, like, and share. And don't forget to tell other students or your friends to watch this video for more information regarding our topic. Thank you so much. Bye.